Sardar Vallabhbhai Patel Education Society managed R.N.G. Patel Institute of Technology, previously known as FETR, is one of Gujarat's leading institute based in Bardoli. The institute is recognized by AICTE and affiliated to Gujarat Technological University. The institute was established in the year 2010. The institute has 5 engineering streams: chemical engineering, civil engineering, computer science and engineering, electrical engineering, and mechanical engineering. The institute has 7 departments, including science and humanities and workshop. The institute has dynamic curriculum, robust and talented pool of faculty members, and state-of-the-art infrastructure in all the departments. It is well known for imparting quality education, active research, and also nurturing students for holistic development achieved through student engagement tools like continuous evaluation, practical-oriented learning, departmental electives, soft skills development, and many more. Recently, RNGPIT has started AICTE approved and Gujarat Technological University affiliated 3 years industry-oriented graduation program, Bachelor of Vocation, on skill development based higher education. The institute has 3 BVOC courses: BVOC in software development, BVOC in production technology, and BVOC in refrigeration and air conditioning. The institute has organized 144 expert talks, 165 industrial visits, 90 workshops, 76 seminars, 32 STTPs, and 20 faculty development programs till today. The institute is proud of its academic results. RNGPIT is continuously securing top rank at state level and zone level in Gujarat Technological University. India's first common engineering facility center, governed by Setu Foundation, is being developed at our college campus. The institute has signed MOU with UGEC Powermax Private Limited Vadodara for skill development, industrial training in wind energy, with Aspiring Minds Gurgaon for the job placement, for Trivedi Global Education Mumbai for the guidance of higher education in abroad, with E-Yantra IIT Mumbai for the development of robotic laboratory, and with Reliance Jio for the development of recruitment and training center in the field of ICT. Training and placement cell of the institute is active and alive. RNGPIT has organized 2 job fairs in the association with Directorate of Employment and Training, Government of Gujarat, and NG Patel Polytechnic. The institute has organized 2 IT job fairs in the association with Surat IT Company Owners Association, SICO Surat. The institute has started SSIP cell for development of innovative projects and patent generation. Various projects done by our students have been presented at National International Expo and Enclaves. RNGPIT has established NPTEL local chapter for various online courses provided by IITs. Institute has run various skill development courses free of cost under Pradhan Mantri Kaushal Vikas Yojana approved by National Skill Development Corporation. RNGPIT has developed Hansaben B. Poonawalla Vocational Training and Research Center with 14 advanced well-equipped laboratories. The institute has developed Tinkering Lab with the Association of Student Startup and Innovation Policy Cell, Gujarat State, in which students can enhance their knowledge in the field of IoT, robotics, artificial intelligence, 3D printing, calligraphy, and many more. The Chemical Engineering Department of RNGPIT is recognized as Schedule 1 Environmental Auditor by Gujarat Pollution Control Board Gandhinagar since 2012. The institute has around 40 industries allotted by GPCB for their audit work. NABL accredited environmental audit consultancy laboratory and civil material testing laboratory of the institute have acquired ISO 9001-2015 certification. There are many achievements done by faculties and awarded by gold medals. Every year, students have been facilitated with gold medals.
Hi, I'm Shweta and I'm a software engineer in Silicon Valley. I did my master's in computer science from California State University, Sacramento, and I did my bachelor's of engineering in computer science from FETR, which now Nozzle is affiliated. I have been asked to share my thoughts on two key areas. So the first one was the campus life. So I can definitely say it was both fun and studies. Studies in the sense that we had to prepare for Viva, GU exams, and for writing essays. And another thing is the fun part was that we used to have two kind of activities. Like one is the visual study, which I personally liked the most because it was of both, combination of both, gaming activities and coding. And another one is the freshers. So in that dancing, singing, and other cultural activities too. So it was very much enjoyable.
Institute awarded with the Appreciation Award for Green Campus at Energy Expo by South Gujarat Productivity Council. In our campus, more than 3,000 trees plantation and 194 number of solar panels with 65 kilowatt capacity for utilization of energy. Students are given full facilities of library with a collection of around 15,000 volumes, 4,000 titles, 30 national and international journals, and 30 magazines. The institute provides facility of book bank and digital library to the students. The canteen facility is situated within the college campus. All type of hygienic meals and snacks are available at subsidized rate. Our institute provides hostel facilities for our college students. Vishwasmruti, Cultural Festival Kashish, Sports Week, outbound training, and festival celebrations are carried out for students' welfare and growth. RNG Patel Institute of Technology strongly believes in all-round development of the students who can shape the better future.
Rathod sir, we are ready to go, sir.
Good afternoon, all. Myself, Dr. K.B. Rathod, Head of Mechanical Engineering Department from RNG Patel Institute of Technology, Bardoli, heartily welcomes you all on the 8th webinar of the Mechanical Engineering Department and 46th webinar of the RNG PIT College of Series 2 under SSIP cell. The topic of today's webinar is types of nozzle and its reinforcement in pressure vessel. And to present such a practical and technical topic, we have with us Mr. Ravi Abuwala, who is an industries officer and manager. And to know more about him, I request Professor Bhargavi Patel to give brief introduction about today's speaker, Mr. Ravi Abuwala. Over to you, Professor Bhargav.
Thank you, Rathod sir. Today, on behalf of RNGPIT and Mechanical Engineering Department, I heartily welcome you all in today's webinar on types of pressure vessel, types of nozzle, and its reinforcement in pressure vessel. As pressure vessel is always been an interesting and vast topic for the researchers. The objective of today's webinar is to share the basics of nozzle in the pressure vessel. So today we have an eminent personality with us to have an expert speech on the pressure vessel. I would like to introduce Mr. Ravi Abuwala sir, who is quite experienced in the field. Sir has more than 9 years of experience in design and manufacturing of pressure vessel field. He has 3 years of experience in GMM Fodder Anand, 1 years of experience.
I think something wrong will have happen.
Yeah,
Internet
sir.
connection is lost, I think. Yes, he's
Sorry,
back.
sorry for the inconvenience. Okay. I would like to introduce Mr. Ravi Abuwala, sir.
Yes, yes. Yes, continue,
Mr. Abuwala
Bago.
has almost around 9 years of experience in the field of. Sir has 9 years of experience in the field of pressure vessel, and currently he has been serving as industries officer and manager at in industries commissioner at Gujarat. I would like to hand over the session to Mr. Ravi Abuwala, sir. Sir, please start the session, sir.
Okay, thank you, Bhargav. Good afternoon, all of you. We will take the sub synopsis of pressure vessel before entering in a nozzle and in reinforcement, because it is very must to take the few knowledge about what is the pressure vessel. So the pressure vessel is the closed chamber which hold the pressure under certain temperature and at the pressure and various fluid condition, whether it is liquid or gas. Pressure vessel will store it. Where pressure vessel is used in the chemical industry, pharmaceutical industry, and the fertilizer industry to derive something chemical, to make certain chemical or the fertilizer or any medicine that the pressure vessel is used to form any chemical reaction. So what does actually it is? It is a closed chamber having a different outlets, inputs. With the its nozzle is nothing but the inputs, output, and some auxiliary connection like pressure gauge, liquid gauge, and other
Ravi,
auxiliary.
sir.
Yeah.
Yes, sir. Sir, can you please share your screen, sir?
Okay. Okay.
Uh, yes, sir. We are ready to go, sir. No issues.
Okay. So this is the pressure vessel. One type of the pressure vessel. This is used for the fertilizer industry to make a medicine. So you can see this is a closed chamber having the support structure to mounted it, having the nozzles which is not generally inputs and output, and some auxiliary connection. This is the vessel entry, manhole connection. So these all are the few connection of the pressure vessel. Among these, we will look at the some highlight of the nozzles, which is nothing but the opening in the pressure vessel. It can be any size or any in the shape. So we will start with our main idea and the topic. Then what is opening? Opening is nothing but the nozzles. So what is that? That is some kind of opening done in the pressure vessel. What actually happen when you done a opening in pressure vessel? The membrane space get disturbed due to the pressure. The pressure is equating all over around the same in the pressure vessel. When you puncture the pressure vessel to do opening, the membrane space get disturbed, and and at the opening area it will stress concentration occurs. So the reinforcement of the nozzle is required for this. So first of all, what is the opening? You can see in this figure in the nozzle position, nozzle in head. There are three main components of the pressure vessel: cell, head, and the cone. So this is the head. So nozzle in head, the first type of the nozzle. Second one is the nozzle in cone. You can see the direction: normal to wall, normal to wall. Second, the pressure vessel arrangement can be normal or the parallel to the vessel center line. Third one, in the nozzle in cone, normal to center line. No, in the cell, the nozzle can be normal to wall or uh, tangential to the center line. So you can see the different type of the opening and in the cell and head of the pressure vessel. This kind of arrangement based on the requirement, the chemical engineer will decide for the chemical reaction, and as a mechanical engineer we have to design from the strength point of view. So these are the different kind of arrangement. Based on the arrangement we have to select the proper designing method. See this, so somewhere in a flat head also there is a opening. So this is the example. This is at the nozzle is at the angular position. It is not the normal at the angular position. For the similar on the flat head, this kind of various type of nozzle we have to design. So these are the various type of nozzle used in the pressure vessel. Now, what kind of shapes will be the opening? Normally, the cylindrical opening is found in the pressure vessel, but based on the requirement, there can be a circular, elliptical, or the oblong. So, pressure vessel can be any size and the shape, but the all corner radius shall be provided with the suitable radius for the smooth space concentration. Now, the type of arrangement of the pressure nozzle with the pressure vessel. When a nozzle is projected inside surface of the vessel, this is the vessel and this is the nozzle. So this kind of nozzle called the satin type nozzle. This kind of nozzle called the seton type. Based on this configuration, we have to analyze it. Now, how to design the nozzles and what will be a correct method? So there are various type of codes available in internationally. You can see ASME, American Society of Mechanical Engineers, Boiler and Pressure Vessel Code, Section 8, or EN 13458 for the European, for CODEP for the French, JI standard for the Japan, Indian standard IS 2825. There are various code available. Among these, the most popular is the ASME, American Society of Mechanical Engineers BPVC code, Boiler and Pressure Vessel Code, Section 8, Division 1, 2, and 3. Division 1 is used for the general and standard type of pressure vessel. Division 2 is somewhat for the higher pressure above the 10-20 MPa pressure. The Division 2 is used. And Division 3 is more than that, about 100 MPa, something like that. So generally, the division 1 contains lots of equation and derived formula for the designing of pressure vessel. Division 2 is the mixing of the some calculation based the formula and the FEA, finite element analysis. There is a very vast in the field of the finite element analysis for the pressure vessel. So what is exactly for the nozzle designing? What is exactly the code adopting? So SME section 8 division 1 UG 36 to UG 45 and division 1 appendix 1-7 and division 2 section 4.5. These three are representing the code calculation for the nozzle and nozzle opening and its reinforcement. Now we will see the what is the actually ASME section 8 division 1. This is the code ASME section 8 division 1. This is the latest version 2019. Every 3 years the ASME will revise or the re-edition the code. So the next code will be in 2022. So this code will guide us to do some calculation In this, UG 37 to 45 will give you the how to derive and calculate the nozzle and its reinforcement. So this is the section for the opening and its reinforcement. Based on this code, we will go ahead. So the scope UG36 to UG45, it contains the formula for the vessel, which is the 60-inch in diameter and the nozzle size less than the one half of the vessel diameter, but do not exceed the 20-inch. For the vessel greater than 60-inch diameter, the diameter of the nozzle shall not exceed the 40-inch as well as the one-third of the diameter. So these are the conditions for the applicability of the ASME section in Division 1 UG36 to UG45. If the opening is not falling under this clause, then we have to move ahead with the Appendix 1-7. This is also in the ASME section in Division 1. So this is covered. Appendix 1-7 is covered only for the radial nozzle, which is the parallel to the vessel wall, and the ratio Rn by R does not exceed 0.7. Rn by R is nothing but the radius of the nozzle, inside radius of the nozzle upon inside radius of the vessel. There shall not be exceed 0.7. And if the opening is not included in the above scope, then it should be properly analyzed by the engineering calculation or the ASME section at Division 2, Section 4.5 or the Part 5. Part 5 is nothing but the FEA analysis. Limit. ASME applies few limits for which we does not have to perform the nozzle calculation. That is, opening in vessel not subjected to a rapid fluctuation in pressure do not require reinforcement with the below condition. 89 mm inside diameter of the nozzle in the vessel or cell, which minimum required thickness or is the 10 mm or less. Second, for the 60 mm for the 60 mm diameter inside diameter of nozzle, vessel required minimum thickness of 10 mm with some limits. This is the when it is for the multiple opening is there, then the ASME gives us the criteria of what should be a minimum center distance between two opening. That is described over here. 1 plus 1.5 cos theta into d1 plus d2 for the cylindrical and conical cell, and for the doubly curved cell or form flat tail. Doubly curved cell means the head or descent on the bottom and top of the pressure vessel, which is actually a distance of the 2.5 times of d1 plus d2. D1 and D2 is the finished opening diameter of the two adjacent opening, and theta is the angle between a line of connecting central line of the opening and longitudinal axis, which is nothing but the angle of the nozzle. Now, what is multiple opening? Multiple opening on the pressure vessel is shown here when the two opening is there, when the three opening is there. Here also a limit of reinforcement is described is over. You cannot give over reinforcement. There is some limit specified in code about the limit of reinforcement, which is I can show you in code. Okay, that is 2.5 times of thickness and 2.5 times of diameter. This is the reinforcement limitation, 2.5 types of thickness and for the diameter. Now, what is reinforcement? Reinforcement is the calculation and strength given by adding area at the opening side. When you puncture a hole in pressure vessel, the stress gets disturbed. So to overcome this problem, we have to provide additional area at the opening. So you can see in the figure, this is the vessel with the opening. At the one side of the center line, we have shown the set-on type nozzle. On the another side, set-in type nozzle. So here the concept of the reinforcement. You can see this is the area required. When you puncture a hole in the pressure vessel, this much area has been removed. So this is the calculation formula from which you can see the how much the area is the required for give is additional reinforcement. Then the area, second term is the area available in cell. So this is area required, which is in dotted manner. Second is area available in cell. This one with the this type of. So what is the area available in cell? So whenever you take and calculate the cell or head thickness, there is something that as per the calculation, suppose example 6.29 is the required thickness. As a safety factor point of view, you have given it 8 mm thickness. So the margin 6.29 to 8, total 1 point something is the additional thickness, which is you can call it the area available in cell in terms of area. So that is already additional strengthening for you, which is already available to you as a cell. So that is the A1 area is already available with you. Always use the larger value. Then A2. A2 is the area available in nozzle projecting outward. So this is the nozzle, right, which is projecting outward. Again, you have find out the thickness of cell. That is a similar manner. Nozzle is nothing but the one type of cylindrical cell. So again, based on the same formula, PD upon 2T, the Ramesh equation, you have to find out the thickness of the nozzle. So this is the Tn required thickness. That is area available in nozzle projecting outward. So this is already we are calculating the which is the area with available with us. Area available in inward nozzle. If your nozzle is projecting inwards, so that is also the area which we can use for the reinforcement calculation. Then area available in outer well and inner well. This is the well which is also the strengthening purpose. So what we are doing, when we punch the hole, the area the removed area which is actually a required area. To overcome this, when you welding a nozzle, the available area like the area available in cell, area available in nozzle wall, area available in well, that we have comparing. And and if this area A1 plus A2 plus A3 and this all area are less than the area required, then we have to provide additional reinforcing pad, which is shown here as a additional welding. This is the additional weld which is used for the, which is called actually a reinforcement, and this give a proper strengthening of the nozzle. So this is the additional area, and this area shall be such a that the all of the summation A1 plus A2 plus A3 plus area available in well plus area available in reinforcing pad shall be greater than area required. This is the common scientific formulation for the reinforcement. So this is the one type of the area giving method for the reinforcement. Now, second thing of the strength calculation is the welding strength calculation. Whether the welding load of the pressure vessel is actually adequate or not. So now, if we imagine this is the vessel wall, this is nozzle wall, this is reinforcing pad. Now, if the vessel is failed, what will be a minimum leakage path for this arrangement? So, ASME indicates three types of the leakage path. First, if the vessel is leakage, the first shall be from this point to this one. So, from nozzle wall, reinforcing pad, and this area, this part. Second can be from vessel wall to reinforcing pad to atmosphere. Third can be through vessel wall to reinforcing pad in the tangential manners. So these are the three possible leakage path. So based on this, the welding total welding load, which is given in ASME UG 41.B2. So this is the additional thing to strength the strength of the weld, which is out of which is the maximum shall be 1. Now the nozzle neck thickness. ASME specify a UG 45 table. Whether as per the calculation you have taken some thickness of the nozzle wall, but the ASME specify the minimum thickness of the nozzle based on the practical approach and later on some experimental analysis. These are as per the nozzle size, the ASME specify the minimum required wall thickness. So your designing thickness shall not be less than these specified values. Another thing, the another criteria given by the ASME is the, this is the TB, TA, and TB, TB3, TB1, TB2. What does it mean? TA, minimum required neck thickness for the internal and external pressure. So pressure can be internal, also external, based on the requirement. TB1, if the vessel is for the internal pressure, then the nozzle neck, and based on its attachment, the minimum thickness can be as per the UG 16B. TB2 based on the external pressure, and TB3 is the as per the table UG 45. Now one thing is I have to uh, came to hear that this is all calculation is based on the pressure only. No additional load is considered here. So if you have additional load, external load like the hanging load or the external attachment load, that has to be separately calculated or the converted in the form of the pressure to evaluate the enough nozzle neck thickness. Now we will see some sort of calculation, how to perform the calculation of pressure vessel. So this is the one time of model of the pressure vessel. Here which the you can see the various type of the nozzles. This is you can see the tangential. This is straight nozzle. This is at the angle. Nozzle is at the angle. This is at the bottom output nozzle. This is some kind of auxiliary nozzle. So this is a 3D model, and this is 2D model of the nozzle with the pressure vessel and some kind of the reaction arrangement. So there are the various software available with the company, but it is based on the Excel sheet calculation and more. So when we see the calculation, when we see the various type of inputs, so there you can specify, you have to specify the which type of nozzle is this. Based on the nozzle, the ASME is given the certain formula, like for the process nozzle there is certain formula, for the manhole vessel entry there are certain formula, vessel with nozzle with the blind flange, with the instruments and inlet outlet and all of these options. For the reinforcement, vessel with the reinforcement pad or without reinforcement pad, vessel can be with or without reinforcement pad, with long welding neck, with the extra thickness provided, butt weld type, self reinforcement, and T type. There are various type of nozzle available with various type of reinforcing element, whether it's satin type or satin type. So based on this is the first thing you have to design and to see for the calculation. After that, the material selection. You cannot use the plate type material for the nozzle, for the small nozzle, for less than the 500 mm. You have to select pipe type material. So these are the nozzle material. For the carbon steel type of the material, for the stainless steel is a SF312, type 304, 316, which are the austenitic steel type. You can see it in the iron carbon diagram. So these are the type of the material for the nozzle wall.
Om Shrim Hrim Klim Glaum Gam Ganap.
So let's see the calculation, which we have discussed over here. The calculation is formed based on that. So this is the same vessel which we have seen. So let's see the calculation. These are the materials of the cell, head, nozzle necks, which is our area of interest. Reinforcing pads, which is the reinforcement for the nozzle. nozzle flange S105. This is the chart of the material. Based on the material, as per the temperature, the allowable stress will vary. You can see this is the temperature in degree centigrade minus 200 to plus 600, and this is the stress. So allowable stress will decrease with increase of temperature. You can see this is a 121 MPa with the, and at the minus 200 it is 214. So with the increase of temperature, the stress will decrease. Sorry, strength will decrease. So this is the code and standard used for the calculation. The pressure vessel design code is ASME section 8 division 1 2017, and this is the material grade used for the calculation. This is the required pressure. The pressure is the 0.9 MPa. The design temperature is 180 degrees centigrade. Height of liquid is 0, and operating fluid is 1. Gravity is 1, which is for the water. The density of the insulation it is, and the radiography of sponge it is later on we will discuss sometimes later. So let's see the calculation of the nozzle and its reinforcement. So this is the various input parameters which is used for the nozzle reinforcement in its calculation. So pressure, we have seen earlier there's a pressure is 0.9 MPa. Then why it is 1.04 MPa is here. So it is nothing but with the addition of the static head. When you fill the vessel with the some kind of fluid or the water, the static head will generate. So you have to also take account the static head with the our required internal pressure, which was the zero point 0.9 plus this 0.14 MPa as a static head. So this has to be included in any type of, whether it is a gas. Even also you have to take the static head of the water, because when you force the pressure vessel, always it is to be tested under hydro test condition before it comes to the end to the customer. So it is necessary to calculate the pressure with the static head only. So that is the clear thing. Then the cell joint efficiency, it is for the welding. It will come with the later on. The material is the SA240 grade 316L. Based on the temperature, the allowable strength is given here. The corrosion we have taken 0. For the highly chemical reaction, the corrosion shall be there. For the fertilizer and pharmaceutical, the corrosion resistance shall be 3 mm at least. So this is the diameter of the pressure vessel, which is 3 meter, and thickness of the cell is 20 mm, and tolerance which is for the seamless pipe. Now the nozzle leg, the diameter of the nozzle leg is the 400 dn, which is actually in the terms of mm 406.4. The thickness is 12 mm, which is NPA 16-inch pipe, nothing but this ready-made seamless type pipe, which we have to punching in the pressure vessel. So these are the inputs. The flange is mount on the nozzle. For connection, he connected it with a different pipe for take the output or the input to the other vessels or the other pumps. This is the required thickness of nozzle neck. This is nothing but the one type of Lames equation, the additional Lames equation, which is PD by 2T. This is a updated version of the Lames equation PD by 2T, which is specified in the pressure vessel. This point 4P is the sum times of empirical addition based on the experiment done by the ASME. This is the thickness requirement as per the UG45, which we have shown in the UG45 table. That is have calculated over here. This is TA, TB1 based on the UG16B and the internal pressure TB2 with the external pressure TB3 from the table of UG45. So this is the nozzle neck calculation formula, which is come out 8.34. So nozzle neck thickness is adequate as per UG45. So this is only for the nozzle neck. But what about the nozzle to pressure vessel junction? That is actually called a reinforcement calculation. This is different from here. So for that calculation, we have taken for few additional data. This is the nozzle at the degree of 17.23 degree from the vessel center line. This is the diameter of opening. This is radius of the finished opening. Internal projection, because 12 mm thickness of the pressure vessel, which we have seen over here. The similar is this. This is the nozzle thickness 12 mm. Height of the internal projection. The nozzle is projected inside 500 mm. So this is what this is. Excuse me. Okay. This is the required thickness of the nozzle based on this Rn, and this is the limit of the reinforcement which we have already talked, which is 2.5 times of thickness or minimum of 2.5 times of thickness of nozzle plus thickness of external cell. This is a limit in terms of the width of the reinforcing pad, which is come out of diameter of the opening or the radius of nozzle plus thickness of nozzle plus thickness of cell, which is actually a specify a limit that how much you can specify the limit. Over there, if you provide an reinforcing pad, that will not affect on the strengthening of your reinforcement. Similarly, for the thickness, if the required thickness is 30 mm and you have given a 40 mm thickness, then the calculation shall be done on 30 mm only. You cannot take the advantage of 10 mm additional. So this is the maximum limit of the reinforcement. So you can play for the reinforcement in this region only. Okay. Now this is the area required formula, which we have seen earlier. Let me open both together for easily understanding. Hmm. Okay. So this is the area required A, this is the formula, and based on this formula, we have going ahead. This is a similar formula, only just Tn by cos beta is nothing but the how much on the angle of the nozzle is. That is to be taken. Why this cos beta factor is over here? When this is the actual thing which we have to see. Suppose this is the vessel and this is the opening. For this type of the job, circular, this simple thing. But when the vessel is this type and your nozzle is attached like this, what will be a opening the shape? The shape is like oval shape, right? So for this oval shape, the finishing opening diameter shall be the maximum. So this is the maximum diameter There is a change in equation is based on this. The cos beta is the factor which taken account the maximum diameter will take place. So based on this, the area required will be higher than what will actually in the cylindrical type opening. So this is what we have done is here. The area required. Now this is the others. A1. A1 is the area available in cell or head, right? We can see A1 area available in cell or head based on our safety factor. This is A2 and A3. A2 and A3 nothing but a nozzle projecting outwards and nozzle projecting inwards. So our nozzle is 500 mm projecting inwards and outwards. So based on this, the calculation is done. Nozzle projecting outwards, nozzle projecting inwards. A41, A42 and A43 is the welding area. So you can see this is welding 41, 42 and 43. So why 42? This is because nozzle is welded inside also. So A41, A42, A43. This is the area. A5. A5 is area available is element. Does it mean that the nozzle is provided with reinforcing pad? Are they fed? So that is the area A5. So A5 is here, and here it is comparing with the area required. Without Fi, the Fi is the given area. So this is the area, this is the required area A, and this is available area with the reinforcing pair. So we can say that the opening is adequately reinforced as per UG 37 of the ASME Section 8 Division 1. Now, Section 8 Division 1 says So this is a one type of nozzle. Now we see the second nozzle. Second nozzle is similar, but in this case the cell thickness is higher. Other things are the same. The nozzle diameter is less than. Earlier it was 16 mm, 16 inch. This is 8 inch. So here this is tolerance for seamless pipe. Actually, whether if it is a welded pipe or seamless pipe, welded pipe having tolerance value 0. For the seamless ready-made pipe having the tolerance of 12.5%. So we have to take less 12.5% thickness in the general thickness. So that is we have to take care. Other things are the similar. Whatever we have done, the things is similar to calculate nozzle neck thickness, calculate the required thickness of the nozzle neck as the UG45, TA, TB1, TB2, TB3, and out of this, maximum of TA or the minimum of TB3, TB1 shall be 7.16 as per the table of UG45. Other thing is the same, only the correct thing is correction or thing to be taken that the whatever the area we have punctured it out, that area shall be filled out with the additional welding pad or the additional giving the thickness of nozzle, nozzle inside or outside. That is the area which we have to take care, and that is the thing which we are following. There are various type of guidance book available on the website or on the other platform. The one book is very useful for the pressure vessel design, not only for the nozzle, also on the pressure vessel design, which is you can note down the Dennis R. Moss version 4. You can find out various formulas and the uh, other things all about the pressure vessel on the Dennis Armos. You can note down and you can study or it thoroughly. If you want to enter the field of the pressure vessel, this book will be a reference for you. Here you can see all types of whatever the things accessories are associated with the pressure vessel. It is included in this book. So this is sure. Now we will going ahead with the calculation of with the appendix 1-7. Here all these things we have shown up to now is the UG37 to UG45. Now what actually appendix 1-7 that we will show. That is useful for the higher diameter nozzle. So here it is. Appendix 1-7. It is used for designing a high diameter nozzle, large opening in cylindrical and conical shell. So here also, which we have discussed, where it is applicable and how much it is applicable. So whatever we have discussed, that is specifically applicable for the nozzle diameter, which does not exceed 0.7, These are the rules, and the nozzle shall be radial only. This is the specified over here. So for this, for the calculation of stress, also the few formulas is described over here as per the case, and based on this formula, this is a simply for the one formula you can find out the stress. This is case 1 and case 2. Case 1 is the with the case A is the RF pad, case B is without RF pad. And based on this, the formula is there for the case A and for the case B. So based on this, the nozzle and its reinforcement calculation is calculated, and phenomena is same to give the additional area for the both cases, but the equation are different for the both cases. 1-7 is somewhat not more conservative than UG37 to UG45. So this is as per the division 1. Division 2 is the somewhat similar like the 1-7, and the part 5 is based on the FEA. FEA gives the various configuration and loading on the nozzles, and it is very rarely used. So most of and in the manufacturing and chemical industry, or the fertilizer, or you can say any industry, 90% of the pressure vessel is built on the ASME section 8 division 1. Rest of the 10% will consist with the European code EN 13445, or British code PVD 5500, or Japanese code, or any other code, and ASME section division 2 or 3. So rest of the 10% will consist these all codes, but the 90% among the of the pressure vessel of the internationally built on the ASME BPVC 2000 section 8 division 1 only. So if you entering the field of the pressure vessel, you have to be a knowledge wise person for the section 8 division 1, and this is nothing but to the refer the code, and you will get the idea that how much easy it is. Once you go throughout, you will find and you will enjoy the calculation. So from my side, that's all. You can give feedback of this topic on the later on. Thank you.
It was a very informative and interesting session, and nice incorporation of the use of ASME section or ASME code for the calculation of nozzle and its reinforcement, because many more of our viewers have only gone through the theoretical aspect of the pressure vessel. But here in this webinar, I think they must gone through the industrial perspective, or we can say the code perspective. So thank you, Ravi sir, for explaining the procedure of the calculations of nozzle and reinforcement as per the ASME code. And now we are running out of time, so I will end this session with the vote of thanks. I deliver my special thanks to our today's expert, Mr. Ravi Abuwala sir, for sparing his precious time for sharing the knowledge with our listeners, and especially the knowledge of ASME code. And I am very grateful to our principal sir, Dr. Latesh Chaudhary sir, and our head of the department, Mechanical Engineering Department, Dr. KB Rathod sir, for providing this opportunity. And the special thanks to our backstage team, Professor VC Joshi sir. A special thanks to Professor VC Joshi sir for arranging this online webinar successfully. And my heartfelt thanks to our trustee Sri Babu Kaka and the management of this institute for providing the continuous support. And last but not the least, I am expressing my sincere thanks to all the viewers for their participation and request them to subscribe our RNGPIT YouTube channel and like our Facebook page. Thank you, Ravi sir. Now over to you, VCJ sir.